right, gentlemen, welcome to your first online notes video here covering EI.1 or a portion of EI.1 notes, linear and absolute value equations. You guys should have the uh, skeletal notes that you can follow along and fill out while you watch this video. If you need to pause at any point in time, make sure you take advantage of the option to be able to pause, rewind, and rewatch things. Let's go ahead and let's get right into the notes. So EI1 is about linear and absolute value equations. This is something that should be familiar to you. It's not any new content, definitely things that you worked with in Algebra 1, but we're going to go ahead and review this, use it as a fundamental base for us to start Algebra 2 and also give us the opportunity to kind of learn the pace of the class here and how the flow is going to work. So let's go ahead and start with a guide to solving linear equations with a single variable. So if there's one variable in an equation, we're going to follow these 4 steps. And if you want to pause the video and write the steps down, you can, but I'm going to show them to you through an example. So let's go ahead and take a look at example 1. It says solve each of the following for the given variable. In 1a, we have a variable x. So the first step would be to simplify the equation. If I take a look at the equation, there's not really anything I can do here to simplify. So then I would move on to step number 2, which is to rearrange variables and constants on opposite sides of the equation through addition or subtraction. So I can do that here. Look over here at 1a, and I have a variable and a constant on the left side of the equation. So I'm going to move this 7 by subtracting 7 from both sides. And in doing so, it's going to change the equation a little bit, but it's going to allow me to rewrite this equation in a way that gets the constant or the variable x away from the constants. Now I'm on step number 3, to eliminate the coefficients of the variable or variables through multiplication. So there is a coefficient for our variable x. This coefficient is -2. I want to eliminate that by taking the inverse operation and dividing by a -2. So if I divide one side by -2, I want to make sure I divide both sides by -2. And so what I'll end up with here is x equal to a -3. And so that would be my solution. So we get a solution once we have isolated a variable on its own side by itself away from a constant or an expression. Let's take a look at another example. Example 1b. I have 4a plus 4 equal to 2a minus 8. So in this case, there's not really any simplifying I can do. I do want to rearrange the equation by subtracting 2a from both sides and subtracting 4 from both sides. That's going to give me 2a with my variable on the left and -12 with my constant on the right. Now I can't eliminate the coefficient here, so I have a 2 in front of that a. So this is 2 times a. I want to take the opposite inverse operation, divide by 2, and I get a equals -6. This is all something that should be very familiar to you. And we can check this. Sorry, I forgot to tell you this, but we can check by substituting that value back in. So I'll take a quick look at 1. If I wanted to check number 1, where my answer was -3 for x, I would just replace the x with a -3 and see what this expression would equal. So this expression would be the same as 6 plus 7, which is the same as 13. And so that would be a correct answer for x. So you can always check your answers in linear equations by substituting them back in to see if the expression is equal. Let's go ahead and take a look at C, another example. Now my variable is r. Here in this case, I'm dealing with fractions. But the same ideas still hold true. I want to get the variables to the same side, so I'm going to subtract 1/2 of r from both sides. And now what that leaves me with is 3/2 equal to, well, if I subtract 1/2 r from 1/2 r, that's going to give me 0. So I get this equation now. There's no variable, and this equation says 3/2 equals 0. 3/2 does not equal 0. We know that's not true. And so this equation specifically is inconsistent, meaning that there is no solution here to r. There's no value for r that you could substitute in and come out with an equation that's going to be equal on both sides. So sometimes when we solve, we get an expression that's not true. Our variables go away, and then we don't have an answer. This is not an equation that's going to be balanced. go ahead and continue our looking at examples. Now in 1D, we see a type of equation where step number one that we haven't executed yet comes in handy. We can simplify this equation. So notice there's a coefficient in front of binomial here. So what I can do is I can take this 3 and I can distribute it. And so what that would give me is 3x minus 3 plus x on the left side of the equation, and then negative x plus 7 on the right side. So I distributed the 3, but everything else stayed the same. Now I can simplify. Notice I have a 3x and an x on the same side. So I can add those two together. So 3x plus x is not 3x. 3x plus x is 4x. So then I would get a 4x minus 3 equal to negative x plus 7. Now I have simplified this equation. And now I can go back to step number 2, where we work to get the constants away from the variables. So I'm not actually going to write out the step, but I'm going to add x to both sides. So that would give me 4x plus x is 5x. I'm going to add 3 to both sides. So that would give me 7 plus 3 is 10. You can write that step out if you need to, but you don't necessarily have to. Now I've got the x, the variable, away from the constant. And so I can simplify by getting rid of its coefficient and dividing by 5. So I'm going to divide both sides by 5, which leaves me x on the left, and then on the right, a 2. So in this case, x will be equal to 2. And again, I can check this by taking that 2 and substituting it into the equation for all the x's and seeing if this equation is going to be equal. Now let's continue on with E. Now in E, we can attack this problem a couple of different ways. So what you might do is what we initially did in problem D, where we distributed the coefficients to simplify the equation. Another thing that we could do here is try to get rid of the fractions. So notice that there's two coefficients that are both fractions. One of them is a 1/4 and one of them is a 1/2. So what I can do is multiply both sides of an equation by a number that's going to eliminate both fractions. And that number in this case, or one of those numbers, would be 4. So if I multiply the left side by 4, remember I'm distributing here. So I would distribute to the first set right here. So 4 times 1/4 is just 1. And so that would leave me n plus 8. Now, there's the parentheses in this case are not very important because there's no coefficient that's being applied to them. So I can get rid of those parentheses. But I also need to distribute that 4 to that negative 2. So negative 2 times 4 is negative 8. On the other side, I'm multiplying by 4, so I distribute that 4 in. 4 times 1/2 is 2. And then in this case, I do want to keep my parentheses because that 2 is in front of that sets of parentheses. Now we simplify. We continue to simplify. N plus 8 minus 8 would leave me with just n. I can distribute my 2 here, and that's going to give me 2n minus 12. Now I want to move my consonants again and my variables to get them on different sides. So I'm going to subtract 2n from both sides. It's going to give me a negative n equal to negative 12. And then I'm going to divide both sides by negative 1. So I'd end up with n equal to n equal to positive 12. So we see here that that simplification process can take a couple steps, but there's also a couple different ways to go around it. In this case, I multiplied both sides by 4 to get rid of the fraction. If you're feeling pretty comfortable with the steps in solving linear equations with one variable, go ahead and take a look at D. Pause the video and see if you can complete D on your own. Okay, let's take a look at an answer for D. So again, multiple ways you can solve this one. The first thing we want to do is simplify. So I'm going to simplify by distributing in this case. In the last case, I multiplied to get rid of fractions because, let's be real, not a lot of people want to work with fractions. In this case, there are no fractions, so I'm going to go ahead and just distribute. And when I do, I have a simplified version of the equation. Now I can simplify further. On the left side, I can combine the 2x and the 10x to give me 12x, so I get 12x minus 8. And then on the other side, I can combine the 8 and the 4 to give me 12x plus 12. Now if I subtract 12x from both sides, that would be 12x minus 12x. That would be 0 on the left, and 12x minus 12x, that would be 0 on the right. I'm going to add 8 to both sides. Now come up with 0 equals 20. In this case, 0 does not equal 20. So this is an inconsistent solution. We have no solution here. Okay, so through the solving steps, we first simplified, then we rearranged, then we got rid of, well, in this case, we didn't really need to get rid of coefficients, but we rearranged, and then we came up with a statement that was not true, so there is no solution. So each of those examples had a single variable. If we look at number two has multiple variables. We can still choose one variable to solve for and follow the same steps that we did with a single variable. So in problem 2a, we have 2x plus 3y equals 15, and we want to solve for y. So we want to get y by itself, essentially. So we're going to treat 2x, though it's not a constant, we're going to treat it like a constant. So the first step here would be to simplify. We can see that there's nothing to simplify there in that expression. Now I want to move the constant 2x away from the variable, the y. So I'm going to subtract from 2x on both sides. There's nothing to subtract on the right side, so I'm just going to get 15 minus 2x. Now I can get rid of the coefficient, the 3, by dividing everything by 3. So y would be 15 over 3, which is 5, minus 2/3 x, or 2x over 3. So in this instance, we come up with an expression that is equal to y. We do not actually come up with a constant that is equal to y, but we're still solving for the variable by isolating it. Let's go ahead and take a look at B. B is a little bit more complicated, but the same concept still solves, or still carries forward. So A is equal to P plus PRT, and we want to solve for P. So the first thing that I want to do is make sure that, notice here, there's two kinds of P's. I want to get the P's together. So let's think about this. If this was problem was, let's say that this was problem was 2P plus 3P. Well, you would simplify this by taking 2 plus 3 and leaving that in front of P, which would be 5P. Almost everybody would say that in their head right off the bat. 2P plus 3P is 5P. What we did was we added the coefficients. So let's actually do that here in B. We have two different values for P. So this is basically like 1 times P plus RT times P. So the coefficients of P, 1, and RT, we would add together. So A would equal 1 plus RT P. Now, what that allows us to do is to remove this coefficient. Now that it's grouped together in one set of parentheses, we can divide by 1 plus RT, and they would cancel out over here, and then they would be left on the other side of the equation. So P is equal to A over 1 plus RT. And that would be our solution here for P. So we still want to work through the same type of steps using inverse operations to get variables by itself to simplify equations. Now let's take a look at equation number 3, or problem number 3. Now we are getting into word problems. There's still going to be linear word problems though. So let's look at 3. It says the largest state in the United States is Alaska, which covers an area that is 230 square miles more than 500 times that of the smallest state, Rhode Island. If they have a combined area for 616,460 square miles, how many square miles does each cover? Well, that's a lot of information. Let's go ahead and let's break this down to come up with an equation. First thing that we notice is we're talking about Alaska and Rhode Island. So I'm going to let Alaska be A, Rhode Island be R. It says Alaska has an area that is 230 square miles more than 500 times Rhode Island. So Alaska is A. It has, so equals, an area that is 230 more. So that means to add 230 to something. 500 times Rhode Island. So this is an equation for Alaska. Alaska is 230 square miles more than 500 times Rhode Island. Now, that's not an equation that we can solve for Alaska in terms of a numeric value. But if we go a little bit further, they have a combined area of 616,460. So what that means is A plus R, Alaska and Rhode Island together have 616,460 square miles of coverage. So we have two equations here. Neither one can be solved by themselves. But we know what A equals. An expression, not a value. But I can replace A with that expression. So I can get rid of A and actually make this 230 plus 500R to replace the A, then plus R that's still there, equal to 616,460. Now this is an equation that we can solve because we have a single variable. So I can combine my R's to simplify that equation. Then I can subtract 230 from both sides, and I would get 501R equal to 616,460. And finally, I can go ahead and divide by 501. And this is going to give me a value for R. So let me pull a calculator up here because this is no easy division problem. So if we have 616,460 and we divide that by 501, oh, sorry, I made a mistake. This should not be 616,460. I forgot to subtract. This should be 616,230. Now, let's try that again. So this, when I subtract 230 from 616,460, that gives us 616,230, and then we divide that number by 501. And this is the answer for R. So the one step that we haven't seen yet is when we have context, when our answers are giving us some information about something, we want to include that context. So what we would say here, you can write you can write full sentence if you want, but just some information, abbreviated information is okay. Rhode Island is 1,230 square miles. This would be good enough. Now, we also want to know what Alaska is. So we figured out what Rhode Island is. Now we want to figure out what Alaska is. And so we could figure that out by taking our answer for R and substituting that back into the equation for A. So if I do 230 plus 500 times R, which is 1230, that didn't work. Let's try that again. 500 times R, which is 1230. Let's go the other direction. Plus 230. Here we go. This gives me the value or the square mileage coverage for Alaska. So Alaska covers 615,230 square miles. So with word problems, we want to make sure we read for information to create the linear equations, solve for the linear equations using our steps, and then put those linear equations back into solutions for applications. Let's go ahead and take a look at problem 4. Problem 4 is a word problem. It's just a little bit different. It says the sum, notice the sum, meaning we're going to add. 3 consecutive even integers is 66. What are the integers? So we don't know what they are. But what we know is that they're even integers. So it could be like 2, and then we would skip to 3, and we go to 4, and then we'd skip 5, and we go to 6, and we'd skip, and we go to 8, and so on and so forth. So every time we go from one integer to the next, we skip one. We move over 2 places. So let's say our first integer is x. We don't know what it is, but it's x. Remember, we're doing the sum, so we're going to add x to something. We're going to add x to the next integer. The next integer would be x plus 2, because remember, it skips over a number. So it's getting bigger, but it's getting bigger by 2 every time it's an even number. So then the next even integer would be x plus 2, which is x plus 4. And the sum of these is going to have to be 66. So these parentheses here are not really doing a whole lot. They identified our even integers, but they're not being multiplied, so we can get rid of them. So what I have here is an equation where I have x plus 2 plus x plus 4 equals 66. I can simplify this. 3x plus 6 equals 66. Subtract 6 from both sides. 3x equals 60. Divide by 3. And now x equals 20. So what are my integers then? My integers are 20. The next even integer would be 22. And 24. Problem number 5 is very similar. But now it's two consecutive odd integers. Remember, with odd integers, they skip over 1 as well. So we want to find two consecutive odd integers. They're right next to each other. So that's, notice, such that the sum of twice the smaller plus the larger is 145. So our smaller one is going to be x. So the sum, 2x, twice the smaller. Sum means to add, so plus the larger integer then would be x plus 2, because remember, we're skipping a number there if we're going from odd to odd, and it equals 143. Now, we can go ahead and simplify and solve. So again, the parentheses here are not doing much. There's no coefficients. I can combine my x's to get 3x plus 2 equal to 143. I'm going to subtract 2 from both sides. I'm not going to show that step, but it's happening. Subtract 2 from both sides to get 141, and then divide 3 from both sides. So I would then take 141 divided by 3, and then x is 47. So what are my integers? The first one is 47, and the second one is 49. And this is a good place for us to stop with day 1 of the EI.1 notes. So today we learned how to solve linear equations, or reviewed how to solve linear equations, and we took a look at some example word problems. On Monday, when we get to class, we're going to go ahead and start to work on the homework assignment that corresponds with these problems. Thank you guys, and I will see you on Monday.